This is an arrangement of numbers you may have seen before. It's called Pascal's Triangle. Blaise Pascal's Triangle was first published in 1665, 3 years after his death. However, the pattern was first developed in China by a mathematician named Yu Yang. But because Pascal was the first Westerner to study it, it's long been known as Pascal's Triangle. The triangle itself is easily made. Notice that there are ones all along the outside, both left and right. Each line is formed by adding together the pair of adjacent numbers in the line above. For example, if I want to fill in the number here in this row, I look only to the numbers above, 1 and 3, add them together, and that gives me 4. To fill in the fifth row here, 1 plus 4 is 5, 4 plus 6 is 10, 4 plus 1 is 5. Notice the rows, this is called row 0, row 1, row 2, row 3, row 4, row 5, and so on. While the triangle contains many patterns, it also helps us with probability problems. If we want to know the number of possibilities in tossing a coin 5 times, we need only look at row 5. If we add up the sum of those numbers, it becomes 32, which is the number of possibilities when we toss a coin 5 times. Each number represents those possibilities. We have one here that represents a toss with no heads. 5 have a toss with 1 head. 10 contains 2 heads. 10 will contain 3 heads. 5 will contain 4 heads, and we'll have one last one that contains just 5 heads. We can also use Pascal's triangle to find combinations. If I wanted to find the number of combination of 3 objects taken from a set of 5 objects, in other words, if we wanted to find 5 given 3, we need to look again at the 5th row and the 3rd entry, which is equal to 10. That means that if I wanted to take 3 objects given 5 objects, I would have 10 different possible combinations. To find 3 given 2, in other words, a combination of 2 objects taken from a set of 3 objects, we'll look for the number in the 3rd row, 2nd entry. That number is equal to 3, which is the number of combinations possible. To find any combination of n, choose k. We just need to choose entry k in the row n of Pascal's triangle. Well, you can see where this could become quite problematic if we were looking at quite large numbers of combinations. Luckily for us, we do have a formula that we can use.